Hi, and welcome back to another Papetti Math YouTube video where I'm going to be teaching you Algebra 1. Today, we're going to be looking at this thing called the quadratic formula. Now, up until now, in Lesson 1 in this chapter, you looked at how to factor to find the zeros. And then in Lesson 2, 3, and 4, it took you through a journey of completing the square. And ultimately, what you were able to do by completing the square is solve for the zeros of a parabola or a quadratic. Finally, the last method that you're going to be taking a look at is this thing called the quadratic formula. And if you look down below, it has this crazy looking formula. And if you were to take the standard form of a quadratic right here, ax squared plus bx plus c, and use the method of completing the square using ax squared plus bx plus c, you would arrive at an answer that looks like this. If you want to take a look at the video in my YouTube channel, it's linked right above right now. And you could click on that to see how you would actually derive the formula from this ax squared plus bx plus c. If you don't feel like doing that right now, perfectly understandable. Let's move on with the lesson. In exercise number 1, we want to determine the zeros of the following quadratics using the quadratic formula. So if we're taking a look at part A right here, and this is all this video is going to be part A, we have 2x squared minus 3x minus 5. Now, what we want to do is first start off by making sure our equation is equal to 0. Once it is, we want to list out what is our A value, what's our B value, and what is our C value. Now remember the A value is the number that precedes the x squared term, the coefficient of the x squared term, and that's going to be 2, because 2 is right before the x squared. Now our b term is the number that's before the x term, and if you're looking at your x term right here, the number before it is, be careful, because you keep the sign of the number as well, so it's going to be negative 3. And finally our c term, c, maybe you could make it stand for constant. The constant, the number that's by itself at the end, is negative 5. Again, keep the sign of the number that's in front of it. So that's a negative 5, not just a 5. Now that you know your A, B, and C terms, though, you're going to use that quadratic formula. That's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And you're going to use this formula and just plug in or substitute in the A, B, and C values that you just listed up here. So that's going to give you a negative, well, what's B? Negative 3, so be careful because you need both negatives, otherwise your answer will be different. Plus or minus the square root of B squared, so negative 3 squared, minus 4 times A, which is 2, times C, which is negative 5, all divided by 2 times A, which is 2. Okay, so we have a lot of numbers here. You could go ahead and you could just put this entire thing in your calculator to get one answer, or you could simplify it piece by piece like I'm going to do right now. So I see a double negative right here. That's going to tell me to make that a positive. So I have 3 plus or minus the square root of negative 3 squared. That would give me 9 minus 4 times 2 is 8 times negative 5 is negative 40. So this is really 9 minus negative 40, or 9 plus 40. So that's 49. All over 2 times 2, which is 4. Okay, there's a couple more things that we could do with this one. And we're going to just continue it up here, right there. And we're going to have x equals 3 plus or minus, because every square root is going to have a positive or negative answer. The square root of 49 is 7, and all of that's divided by 4. So our two possible answers here, and I say 2 because we have to do the plus version and the minus version. Let's start with the minus. We have 3 minus 7. That's negative 4 divided by 4 would give us negative 1 as one of our solutions. And then 3 plus 7 is 10, and 10 divided by 4 is 2.5, or 2.5, which is the second one of our solutions. So you have two solutions here, or roots, or x-intercepts of this parabola, and those two intercepts are negative 1 and 2.5. So again, if this video was helpful, press the thumbs up button. If it wasn't, tell me in the comments why it wasn't and what I could do better to help you out in the future. Okay? And if you want to click on the video that just popped up, that will let you go straight to part B.